So, this is a practical talk. This is a practical talk about how Houdini solved problems for me. I'm going to talk about how I learned it. I'm going to talk about what things look like today, and with some ideas about what it might mean for us tomorrow. Yeah. So, let's start with the basics. What even is Houdini? So when I started learning about Houdini last year, I wasn't even sure what it was. I didn't understand how it worked. I didn't understand how it was being made, and I didn't even know why it was called Houdini in the first place. So here's the official definition, and I felt there was a lot of missing detail. It goes like this. CSS Houdini is a W3C effort to define lower-level CSS DOM APIs for authors to understand, recreate, and extend high-level CSS authoring features. And that's great, but I felt there was a lot of missing detail. So here's my summary. Houdini is a toolbox that future-proofs styling. So in the future, browsers that support the layout API will be able to polyfill container queries, which is something we've been waiting for a long time, before they go stable in browsers. But to use Surma's example, right now, today, in Blink-based browsers, you can use the Paint API to display conic gradients with native performance. And that goes down to mobile as well. So the way that it works is this. Going back to the original quote, it explains how Houdini is being developed. Browsers give us the tools to experiment with. We feed back on our experience. Like, we can't do masonry without JavaScript. Emergent patterns can be formally adopted by browsers. And then it's rinse and repeat. So the quote from the Extensible Web Manifesto, which is the underlying idea behind this all, is that involving web developers in the process and iterating outside of the browser avoids the platform getting stuck with bad APIs. And we've been here before. So it's worth taking the time to get the right primitives in place. What we're getting now is we're not going to be stuck in the present. We're going to be building on top of the APIs that we see here now. So this is a non-exhaustive list. So what does Houdini consist of? Here are the big name APIs you may have heard of. Paint allows programmable imagery. Animation allows scroll-driven UIs. And layout gives us things like constraint-based layouts and masonry layouts. But they're all part of the family of worklets. The APIs that we write custom code for, but there are more fundamental features that lie beneath them. So we've got the typed object model, and that gives us interoperability between JavaScript and CSS. We've got the properties and values API, and together, the whole lot makes up Houdini. And as I say, there are additional APIs coming. So let's talk about worklets. They're isolated JavaScript contexts, like web worker-ish, but they must be parallelized. They must be invoked by the rendering engine. That's to say, we have no control over when they get executed. And they have almost no access to the global scope. Now, these might seem like downsides, but they're really not. What they are all characteristics that allow for really super aggressive optimizations by the browser. They can be migrated to a different thread. They can be killed off. And they can be allowed to fall out of sync with the main UI. And the reason that's part of the spec is that although your UI might have a bit of jank, at least it stays responsive to the user. And that's much more critical. So they've been described by Sam Richard as the foundation on which Houdini is built, and they're the primary mechanism by which the whole apparatus operates. So worklets also include the Paint API, which is a canvas-like drawing context. If you've worked with the canvas before, it'll feel very familiar. You can paint anywhere the images are supported, so that's border image, background image, and it's already shipped in Blink-based browsers. So this is an example from Una Kravitz' awesome extra CSS library. Looking at the code, you supply some variables to configure the size and shape of the confetti itself. And then using familiar CSS syntax, background, paint, extra confetti. So the animation API, this is a doozy. It allows animations based on user input. And traditionally, this has been very, very hard to make performant. So it unlocks performant parallax, but please exercise caution when doing parallax-based interfaces. The canonical example is probably this one by Surma. And you can see that on scroll, His little avatar scoots up into the top. It's an addition to the Web Animations API, and it's pretty complex, but it unlocks the potential for some amazing user experiences. And the linked article down here is an absolute masterpiece of explanation by him. So, the Layer API. So I work for the Financial Times, and for news sites like us, container queries are going to simplify everything. And I want to explain, I want to emphasize this point. When browsers make the container queries possible, that's going to take a while for them to standardize on something that works for everybody. Houdini gives us the opportunity to produce solutions that work independently for us, because we don't have to solve everybody's problem. That's why it can move independently of the spec release. So, the wrap-up for worklets. Moving on to the primitives. The typed object model. So we have a CSS object model already, but it's pretty slow and it's pretty flaky because everything is treated as a string. This preserves types between JavaScript and the CSS, and it's already shipped in Blink-based browsers. So let's step through the code. Here's the old example. If we set the opacity of an element to 0.3, but then we read it back, what started as a number has ended up as a string. And that's clearly difficult for us, because it's going to introduce all kinds of bugs when we try and do addition with strings. We'll end up with 99 when, in fact, we meant 18. In the new typed OM, if we look through the attribute style name, we can set the opacity, then when we read it back, we get an object that clearly states that it's a value. It's a CSS unit value that has a value of 0.5 and is a number. And when we're trying to read from style sheets, instead of having to effectively guess, if we look at this, the background position, we're saying center bottom and then 10 pixels from the bottom. Before I got into Houdini, I wouldn't have really understood how the browser makes that calculation. But it's explicit here. So we create an instance of the computer style map, and then reading back the X and Y positions, we can see that we get a sum operation that gives us back values, an array of values that are very explicit about how they actually work. So again, going back to the original definition, this is Houdini helping us understand how the renderer treats these instructions under the hood. OK, so the properties and values API. This allows us to the JavaScript syntax is the current one, and it's being used to spec out the eventual CSS syntax. It's still behind a flag. But what we get is we define the name, we define the syntax, and this can be one of a range of syntaxes, anything from URL to string to number to color. We give it an initial value, and we tell the system whether it inherits or not. So this is an example of the iterative pattern of improvement when we see the CSS definition, where you can see that it's more compact. We specify the name. It's baked into the declaration, and then it shares exactly the same properties. So we're iterating in JavaScript. We're seeing how it should work. We're seeing whether there are any problems with that specification. And then once we've identified that it's good for everybody, at that point, it can be baked into the CSS. So there's also a polyfill, which allows you to use the new CSS syntax, but it will actually author the JavaScript for you. Yeah. So then what's in a name? So this is Harry Houdini. He's about to lock himself into a vault from which there is no escape but certain death. But it's really a reference to CSS being freed from the shackles of browser constraints and their release cycle. OK, so how did I get my start? I'm a strong advocate of TDD. That's Twitter-driven development. And this is my friend Sarah complaining on Twitter that you can't animate gradients in CSS. And I wanted to understand why. And she's absolutely right, but let's dig into it. So here's a typical linear gradient. It has two key characteristics. One, it's rendered as an image. And two, once it's defined, that's it. That's the last opportunity we have to interact with it. But what if we were to use custom properties as the color stops? Jeff approves. Here's how we might do that. So in the first instance, we specify the gradient start, we specify the gradient end, and then we apply them to the linear gradient. And because we can do that, all of a sudden, now, we can do this effect. So this is a linear gradient being animated in time. And it'll run for a certain period of time, and then stop. And the way that it works is we define the gradient, we define the gradient start, the gradient end on the root element, which is the HTML element. We then apply that to the body, and then finally, when the mouse, when we listen to the mouse move event, we look at how far across the mouse is. We work out the new values for the gradient start and end. And then we apply them to the root element. So by doing that, because they cascade, that's what drives the animation. But here's another thing that I want to point out about the animation. If you look at the top and bottom, those are pseudo elements that are applied to the paragraph that says, I whip my mouse back and forth. Now, pseudo content that I wanted to read from the custom props that I was changing. So as the custom props change over time, I want that HSL value to read 121 or 241 directly from the CSS custom properties. So my first idea was, all I have to do is plug it in here, right? But it didn't work. And the reason it didn't work is that the content property has to be a string. But in this case, it's not stringy enough. It's being used as a number or a color to drive the animation. So that was when I first realized that CSS is a typed language. Lara, in her other talk, has taught us that it's Turing complete, but it came as a surprise to me to find that it's already typed. So what did I actually have to do? It turns out that with a bit of hackery, we can do type juggling. So we define a counter reset. We create two custom idents called hueStart and hueEnd. And then when we read off them in the before and after elements, that has turned them into enough of a string that they will actually appear, which is kind of bonkers. So after all of that, I have to conclude, Sarah's absolutely right. These are all hacks. And there's a part of us that likes being very clever with CSS and like sort of hacking our way around the problems, but it's tiresome as well. Anyway, I put it from my mind until about a month later when all of a sudden I saw this. It says, a designer on my team just revealed to me that he made a Jeff Goldblum Ipsum generator, and oh my God. So I was like, well, okay, this tweet is going pretty viral. So I checked it out. And I mean, she's not wrong. So what we have here is, the design is absolutely stunning. It's fully responsive. But what really blew my mind was the way in which the dominant colors were being picked from the images and then applied to the gradient and then smoothly animating between the two. So my initial reaction was, hats off. But then I was like, I wonder how he's done that. So digging into the code, it turns out that we have stacked divs. They're being moved on top of each other, they're having their opacity animated, and their Z indexes are being updated. So it's a bit like this. It's fakery. And it's not very performant either. So the browser is doing this work, and fine, animating opacity and transforms is performant, but it's still having to happen on the main thread. That's not that great for performance, because the browser's working pretty hard to paint all these surfaces. So here's roughly how the markup works. First, we specify some divs that are going to hold the background information. They're going to be containers for these linear gradients. They're going to be painted into them. And then there's a bunch of images, and they're going to be slid over the top of each other. And then the whole thing works together, but then we have some images, and everything for which gradients to use for which image is specified in JavaScript. So that's slightly problematic for me, because when people say that CSS isn't a programming language, they don't realize that it is. It's just declarative. So in exactly the same way that in React, we get to specify the end states of things and let the system figure it out, I like systems where we tell the machine what to do, and it takes care of the rest. So in this model, this would be better. That's to say, I would be able to have any number of images paired with the color stops, let the program figure out what to do with them, and that way I can have a declarative interface. But as we've seen, it's really, really difficult to work with data values when these are typed as strings and when we know that we can't use them as colors. What I'm really aiming for is something where I can have a single background that updates when I load an image, use an embedded gradient instruction to animate the next gradient. And if I want new content, I can add or swap out with new color stops in the data set. So all I need to do is figure out how. So first of all, I tried to apply custom props to a keyframe animation. It didn't work. Why doesn't it work? Well, colors are numbers. A hex value is a series of pairs of numbers. And when everything is a number, the browser knows how to get from one number to the next. It can interpolate between them. But if the values aren't numbers, and as soon as we change the value of a custom property, it stops being a number and reverts to being, well, anything, kind of stringy. They don't have a fixed type, so the browser has literally no idea how to get from this to this if it's not sure what the starting point and the end point actually are. Because it turns out that custom properties are just spicy strings. So, how I learned to stop worrying and love Houdini. Register property is our friend here. As we've seen, it lets us define the names of the gradients, the names of the values that we want, the syntax that we're going to use, the initial value, and whether they should inherit. We register the property, we tell the browser that this is a color, and then we can optionally give it an initial value. We can tell it that it's inherited. And now this is going to look like a wall of code, but it's actually a little bit simpler than it looks. So first of all, we take the Jeffs from the DOM. That means that we can add any number of Jeffs we like. Then we have a show Jeff function, and it takes the current Jeff, it grabs its gradient style and information, and then it applies that to the background, and then it sweeps through and animates the portraits. But in the background, this is all I had to write to get a smoothly transitioning gradient. Because we're listening out for changes on known types of gradient, everything is automated. So let's see that in action. So here we go. Everything is buttery smooth. It's a declarative interface. There's nothing on the main thread. Everything's running at 60 frames per second. I can't hear the fans because so little work is being done, and any work that is being done is being done in parallel. The custom color props cascade. So as you see, if you watch that button there, it's now it's morphing with the dominant color from that corner there. And so is the little forking mechanism that you have there. Do go and fork this. It'll be fun. So then I wondered what it would be like to add a fully responsive masonry layout. And I can't show you here, but this is all the code that it took. So that when I click the button, it lays out all of the images from the IMDb movie database. And when I saw that it was that simple to achieve this was my reaction. So let's talk about what's true, because this is all very well, but if everything's behind a flag, how true is it? How soon is now? What can I do now? And this is a widely experienced feeling. So can anyone help me get excited about Houdini? I feel the same way about it as web components. Maybe me. So this is why someone might feel that way. If we go through, we can see that, OK, Chrome is looking pretty good, actually. In fact, it's even ahead of the W3 spec itself. But progressively, we get worse and worse. So Firefox, well, they're busy building Servo, so they're forgiven. Opera, less concerned about them, but they're Blink-based, so they're going to inherit everything anyway. Samsung Internet, likewise. Safari, they're working on it. The elephant in the room is this giant column of red. So how soon is it going to be that our Windows users, and let's face it, the bulk of my users on Windows, corporate clients are on Windows, how soon are they going to be able to experience Houdini? How soon can I practically develop using Houdini for them? Well, the answer is pretty good. Because Microsoft have just released Chromium-based Edge. They've stopped their own development effort. They've stopped duplicating that effort. And they've adopted Chromium as their rendering engine. And it's actually pretty good. In fact, you've been watching, everything you've seen so far is running through Microsoft Edge. That makes me pretty good. What's even better than that is that once it goes stable, it will be available right down to Windows 7. So it's going to be like a grid-based situation, where all of a sudden, the world is going to change. And initial support is going to be better than Flex was, or Grid was. So the whole point of the extensible model is that we're already beginning to see Houdini features way in advance of the spec being complete. So to Damien, courage, mon vieux. OK, so how do I get started? How do I get started with this process of learning Houdini for myself? Well, for me, this was my Bible. It's by Sam Richard. It's the Houdini spellbook. It's up on Glitch. And it's a brilliant overview. It deals one by one with each one of these APIs, and it helped me understand exactly how they fit together. It comes complete with examples, and it's a brilliant work of explanation. Next up, awesome CSS Houdini, which I think is actually a Barcelona product. Shout out to Juan. It lists videos to watch, people to follow, and articles to read. Next up, we've got Vincent Oliveira. He takes the examples of the Chrome team, puts his own spin on them, and does incredible things. So in this case, he's combining the layer API with SVGs so that you can edit the curve and fit as many bubbles as you want according to parameters that you've laid out here. It's really, really impressive stuff, and it's very, very clearly explained. But the daddy of them all, the people who are actually working hardest on the spec itself, actually building the APIs themselves, are the Chrome team. So go and visit Chrome Labs, go and visit developers.google.com. The quality of the material there is excellent, and you'll be able to see the real capabilities of the layer API as we build diamond-shaped elements in the browser, for example. So I have some closing thoughts. I think Houdini is important for a bunch of reasons that are outside of the specifics of the API. It's going to give us shareable, reusable drop-in code. As we've seen, the CSS syntax is relatively unchanged. We're going to be defining backgrounds. We're going to be defining borders. But we're going to be able to pull in pre-computed worklets. Like, for example, I didn't write the masonry worklet. And it's going to be an open source affair. So, for example, you'll be able to download things like the confetti from Una's library, and I would implore you to go and contribute to it there. Go and contribute your sassiest ideas. The next one is that Houdini is great for performance. And there are two kinds of performance. There's performance to the device, and there's performance on the device. So in the case of my application, I got a masonry layer, I got the full gradient animation, which would have ordinarily cost me GreenSock plus Masonry.js, hundreds of kilobytes of JavaScript, 3 kilobytes. And then there's performance on the device. I was getting 60 frames per second across the board because everything was so aggressively optimized. Houdini is a progressive enhancement. So we can fall back to anything. We can go wild with Houdini features, but we can also build them on top, and we can gracefully degrade from the pinnacle right down to something that's very, very straightforward and functional. So in the case of this, we could still build the full experience using Masonry and GreenSock, but we could fall back to something that was much, much more static. So depending on our users' needs, we can adapt. It's also going to help us write more robust code. As you've seen, we have to do much less thinking about whether something is a string. Everything tells us exactly what it is and how it works and what to do with it. And in the case of some APIs, we even get variable clamping. So for example, you can't set opacity of 3. Nothing works above 1, so it'll clamp it intelligently to 1. But as a final thought, I think of our community as developers that build user experiences. It doesn't matter to me whether you write JavaScript or CSS or both in either. We're all trying to make beautiful, useful things. But there's been a lot of friction in our community, often about purism, it feels to me. Your JavaScript has no business in my CSS and vice versa. So the big lesson I take from Houdini is this. CSS loves JavaScript. Thank you for coming to my Jeff talk.